Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And this video today is going to take a look at the C++ programming language. We're going to develop a playing card class and a manager of playing card objects, otherwise known as a deck of cards. So, everyone, very many people, so many people have used a deck of cards, so I'm not going to describe how cards work. We're just going to get right into the nitty-gritty details of implementing these. I am starting with a completely empty project, and I'm going to get started right now by just saying I'm just going to call it card. I could call it playing card, but I'm just going to call it card just to keep it easy. And I'm going to set up class card. And maybe something we don't have to do, but as we get into more and more advanced programming in C++, we get into object-oriented programming, obviously, and we get into inheritance polymorphism. And a playing card is one thing, like, ace of spades or whatever, but what if I were ever going to maybe even consider working in the realm of, like, Magic the Gathering and any of those other crazy card games that are out there? Like, I am going to work on making sure I have a virtual constructor. So maybe this thing is a base class for other cards. Maybe, maybe not, but it doesn't take much extra work to get this ready for that up front, and it takes a lot less work for me to do it right now than it does for me to do this in other places. So I'm going to set up the rank and the suit, because those are the two parts of a playing card, right? The three of clubs. There's a graphic. I'm saying, like, how far down do we abstract this? How simple do we keep things? I'm thinking of this from a text-based standpoint. I'm not thinking of this from a video game standpoint, where the card could have access to a different graphic or anything like that. And so I'm going to keep track of the rank over here. I'm going to keep track of the suit over here. And just from the standpoint of just getting something going, maybe just a function for the get functions for rank and suit. So right now I'm just setting all this up. I'm going to change some of this around in a couple minutes here, but just to get the basics of what the understanding of what I'm going to do, what I'm going to set up. And I'm also going to get face value, because most games, many games out in the world, like blackjack especially, a jack, a queen, and a king is a 10. An ace is a weird one in blackjack. It can be a 1, it can be an 11, but say, like, we have to pick a value for ace or something like that. But other card games maybe have different values. So since I'm just playing around with the idea of virtualness, maybe I'll just set this get base value up as virtual. So someday maybe you could go ahead and derive from card and change that function up. And maybe you might even have to do that for rank and suit. But I have more of a feeling that if I were going to do that, I'd have to reevaluate what a card is altogether. I am not setting up any sets, so once the card is set up, you cannot go ahead and go in and change the rank or suit. So just like you can't go to a casino, wouldn't that be great if I could just go to the casino and just change cards into whatever I want? It would be even better than having an ace up my sleeve, right? I could just change whatever I want whenever I want it, and probably no one would even be the wiser because of the way set functions can work like that. But that's not how we're going to do things. So another thing I want to talk about are enumerations. So instead of having int values for the rank and the suit, I can also set up enumerations for the different types of things. Let me hit Alt number pad 3. I get a heart. So I can say hearts equals 3. And what did I do? I hit on the number pad. I hold down Alt and I hit 3 on the number pad. It has to be on the number pad. And it brings up what the ASCII character is. So a 4 is a diamond. And a 5 is a club. And just to make sure, 6 is a spade. All right, and this is just to keep consistent. If I can print these things out as characters, then I will go ahead and do so. I will call this rank or suits. And then I will change up and make the same thing go for enumeration for the ranks. And so 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, and I'll call an ace on the high side. And again, the ace is one of those things that kind of throws things off a little bit, especially in blackjack, because it's high. It can be a high card, it can be a low card. Some games it could be either or, you know, it just gets complicated, but let's just leave things alone. And so now we have two enumerations set up, so I can use these things in lieu of using integer values. So I can say, okay, give me a ranks. You can call it rank type if you want, you know, whatever it is that makes it. And I can say suit types or suits. And I think what the problem here is I have to specifically say card : : Is that gonna throw? Is that the problem or not? Or did I not do the syntax correctly? Uh-oh. Incomplete type not allowed. Did I just put this in the wrong place? Yeah, that's all it is. Okay, no problem. I make mistakes just like everybody else. How many languages do you work in a daily basis when you're out there in the world? Can't remember all the little stupid details for everything. There we go. But you do need, well, now do I need to supply the card : ? Let's see. Oh, not here anyway. Okay, so now I have everything that I was thinking about set up. So now I can just go ahead and implement. On over to card.cpp. Last time I tried this, everything crashed. Yep. Shit. What is wrong with my Visual Studio? Okay, so it actually, since I didn't save it, I had to go in and retype everything of my Visual Studio problem. But I think I neglected a few things, so let me just go through this one time quickly again. So I have class card, I have a public enumeration for the suits. I don't need 3, 4, 5, I don't know why I was doing that. I think I just got ahead of myself. So hearts start from 3 because again, that's the ASCII character if I ever wanted to change an enumeration into an int or something like that. And for the ranks, I probably neglected the equals 2. 2 equals 2. So this just gives me a named component for the integer values from 2 to 10, and then I can use Jack as 11, Queen as 12, King as 13, and Ace as 14. And so, yeah, I think I forgot to do this kind of stuff down here. Now I pass in ranks for the rank, suits for the suit, so I can't really pass in an integer value per se. So this kind of makes things nicer because now instead of having int, like what's what? Is it a rank suit or is it suit rank? Now the user or the people who use my code, the developers are using my class, absolutely know they have to set up the rank before the suit. I still have my virtual destructor. I have the get rank, which now returns a rank value in enumeration. Same with get suit. And the get face value also now, or just didn't get changed, is now still virtual, returns an integer value, which is its face card value. And now the rank is a ranks, the suit is a suits. Because enumerations are just fancy integer values, but basically they have their own rules and they have their own types and they have their own other things. The interesting thing about this now, if I go over to the CPP part of things, is that it generated all this for me automatically, yet it's bitching and moaning. It says suits is unidentified, and it's like, well, why would you set this up for me? Why couldn't you just say, this is what I want here? I want to return card. I have to, does everything fix up once I do that? Yes, because ranks is part of card. It's inside of card. So if I'm inside card, like everything else, I have access to everything public and private. But when I'm outside, like even out here, defining this function, this is basically global. I'm not technically in the class until I get inside of here. I'm not inside, the member function. So even right here, I have to supply card : : to tell them what's going on. And I don't need anything inside this here. A virtual destructor is only here so that I make sure that if I ever derive from this, I don't have any memory leaks of any kind. That's the only reason for that. And then I can say here, rank gets rank and suit gets suit. Oops, other way around. And I can just steal this guy. Nothing here for the body of the constructor. All right, so instead of this, I can just return, I don't have to just return rank. And here I can just return suit. That's easy enough. Get face value, that's the only tricky one about this, and then we're ready to move on to other things. So using my enumeration type is to say here if, and this is, I can actually do something like this as long as I don't, this is one of those things. If I change this, I have to go change my code, but I can say if let's see here, if my rank is less than or equal to 10, and now I'm inside, so I can do this. I can say return rank, or I can say return rank as a static cast into an integer. I can turn my get face value, so a 2, let's say a 2 will turn into a 2, a 3, a 4, 5, 6, 7, 8, 9, 10. Will return anything from here, 2 to 10 will return its value. So Jack, Queen, and King, that's the only tricky part. Now I have to watch out for that here. If rank is less than or equal to King, then I can just return a 10, because these are this is 11, 12, and 13, and I need to change that into 10s. And then the last remaining thing right here is the ace, and as I was saying before, I'm just going to return that as an 11. I'm not going to return it as a 1. I'm just going to return it as 11. So this cuts down greatly the amount of code I have to write, especially if I have to do if statements. If it's a 2, return 2. If it's a 3, return 3, and so forth and so on. And so this does pretty good. Everything up to 10 return its value. From Jack, Queen, and King is all 10s, and then the ace is going to be an 11. Okay, so that's pretty much all I wanted to cover for this part of my lecture about just setting up a basic card class that can be used for many, many different types of card games. So now a card manager class, usually they're called, like my recollection over the years is they're called manager classes, when basically the card is being, a bunch of cards is being managed under the hood somehow, and that's a deck of cards. So I'm going to set up a deck class. I want the H file here, the header. Okay, so class deck, and I'm going to have a public and a private. And so again, we're keeping track of a ton of these things. So what should I include? I should definitely include vector, because under the hood, I would love to have a vector of card pointers. I'll just call it the deck. And the reason why it's going to be card pointers, and I'll include it first here while I'm thinking about it. The reason I'm including it as a pointer is that if I don't keep track of them as pointers, then all of the code will compile and figure out what virtual functions, or quote-unquote virtual functions, to run at compile time and not at runtime, and you will lose all of the virtualness. That's why pointers are such a big deal once you get into advanced C++ and out into the world, because without this pointer, without using pointers and without using virtual functions on top of it, you never get the dynamicness of the polymorphism in action. I'm going to set up a deck of cards. I'm going to set up a constructor. And just for the sake of this, I'm not going to put anything in here. It's just going to set up a deck of cards, a 52 card deck of cards. Let's see, I do need a destructor because I have pointers and I'm going to be newing them up in the constructor. I'm going to need to destroy them when this deck object falls away. Otherwise, I'm going to have a huge memory leak. Every card I new up is going to be lost to time and lost to the operating system, and things are not going to go well. So let's just start here, and let me set this up here. And I know better now than to try to make everything nice. Sorry about that. I don't know why my computer is acting up. It's only started in the last couple of videos I've been trying to make here. Okay, so for the destructor, I'm going to have a vector of stuff here. So I can say for every card pointer C that's in my deck, or if you want to say lowercase card, if depending on how you like, in my deck of cards, all I have to do is say delete card. But if I don't do this, then that's the memory leak again. And oops, what did I call lowercase d? Sorry. Or maybe whatever. We'll just keep it that way. I know my my capitalization is a little off, but I'm just gonna go with it. I'm gonna go with it right now. So delete card, and if you feel so inclined, you could always go ahead now and say deck.clear if you really want to feel good about it. If I just do deck.clear without this, it doesn't delete anything. Just because I clear my vector, I'm not deleting the data. So you have to watch out. So that is my destructor. And now, just for the sake of this, I like to, even though I'm setting it up like this, I'm setting it up as using the default constructor. I want to make sure I reserve 52 spots because I want to make sure I don't have to do a ton more copies and more than I have to. So this tells the vector that, hey, I think I'm fairly confident I'm going to need 52 spots to reserve. Can you give me a memory block that holds 52 of these pointers? And he goes, sure. Here's 208 bytes for you. And so the next thing I want to do is set everything up so that I can put the cards in. Okay, so to do so, all I really have to do is just set up a for loop and say for every, okay, this is the fun part, for every rank and suit. And so for every rank, I'm in deck, so I don't, or do I have to? No, I'm in a deck, so I don't. For every card, rank, I guess I'll call it R, and then the R equals, and this is where the fun is, card, and I say, okay, I'm doing ranks, so I got to start with the 2. Where's my 2 here? And this is, again, this is where things can get a little tricky, because if someone goes ahead and modifies under the hood what a 2 is and what, like the numbers and the values and things like that, your code can be taken away from you and can fall from underneath. So you have to watch out. R is less than or equal to card, ace, 2 to ace, plus R. Can I do that? That's the fun part. Can I do this? No, I can't. Oh, it's ranks. And here's the fun part. I cannot just increment. I can't just increment an enumeration. So I have to, this is the fun of things. So maybe I'll just do a while loop. Well, like how do I increment? So I can take R, and since I know, say this is another one of those things, I know with my enumeration, I just hate enumerations, but I'm doing it just for the sake of it. But what I can say here is I can say take static R equals, I could put this here, R equals plus, and then I could say static cast into int by R value. I think I can do this. No? Maybe I need one more parenthesis. Modifiable L value, static cast into an int, increment it, R equals. All right, I kept that in just for how ridiculous it gets, but this is how ridiculous it can get to do a for loop with enumerations. And when you start doing things like this, you realize, yeah, there's a reason why you're not supposed to do things like that. Because I'm taking the integer value of the rank, turning it into an int, adding 1, and then converting it back into an enumeration. The reason why this is so god-awful and you should never truly do it is, again, you have to be careful. Coming back here, like I'm allowed to say like 4 equals 54. And what does that mean in the enumeration? 2 is 2, 3 is 3, 4 is 54, 5 is 55, and so forth and so on. So just because I can take an enumeration like 3, convert it into like the number 3, add 1 to make it a 4, and then convert it into an enumeration doesn't mean it does anything. It doesn't crash, but I have an invalid enumeration at that point of because there's no such number as 4. So I'm just saying you have to watch out for those kind of things. But in our case, we do know we go straight up from 2 to 14. So as much as this is horrible stuff, turn my rank into an int, add 1 to it, turn it back into a ranks, and then go ahead and then just, this is the equivalent of plus R. And now we can go with it. And I got to do the same thing here for the suits. The suits is card, and so I got to remember I use the hearts first, and then the spades last. And then again, instead of converting all of this, I'm going to convert this into suits. Okay. So now, just for the sake of this, I'm going to print out R, and I'm going to, and this is supposed to be S here. So this is what you get for doing all this stuff. Okay, so I got to make sure this is S. in 4 places here. Okay, print R, print a space, print S, print an N line. And I do need to include IOStream here in the moment. Okay, and I don't have any main function just yet, so let's go ahead and set that up, and let's just make sure we're where we need to be. New item, give me source.cpp, give me include give me deck.h, turn 0, system pause. Okay, now I say give me a deck of cards. I'll call it deck lowercase, and let's see what it prints. And here we go. So now, after all of this, we have 2. This is where, again, the integer values don't really scream out that we're doing things right, but I've got 2, 3, 4, 5, or 2, 3, 2, 4, 2, 5, 2, 6, and then I've got 3, 3, 3, 4, 3, 5, 3, 6, and so forth and so on, all the way up to 14. So I think we're doing it right. And again, it's not necessarily right. Maybe we can maybe we can figure out a way to print out the card type here. And so because of the way things work, I'm just going to create a quick and dirty function called a void function called print. I'm not going to set up the inside of the card class. I am not going to overload an operator here or do anything like that. I'm just going to set this up. I will implement it, and I'll print void. And now what would be nice here, I'm going to use cout. So do I need to include, yep, I'll need CPP file here. I'll need to include IOStream over here on this end. And of course, again, this is just to get you started. If you really want to spruce this thing up, that's up on you. And so now, is everybody happy here? What's wrong with card class? Oh, unscoped, all the new rules and all the new things. Okay, so what I want to do is print out, and so I can't. What'd be cool here is I could just static cast or whatever like that. But what I can do here for the rank here, and I can do cout. No, I can say if my rank is less than or equal to 10, then I can print out the value, the number, as a value. So I can cast it, or I guess in this case I can just print rank. And then here is kind of where you need to, else if rank equals Jack. Let me get rid of my normal rules here just so I can get this thing going. So I can say print Jack, Queen, King, Ace. This will just be an else. Queen. Anybody remember that band? Queen, King. Are they still around? I don't know. Or Ace. Okay, so that takes care of the rank portion. And so, but the 10 can be and this is good. I just want to keep things a little more consistent here. So what I can do here is just say else if the rank is on 10, print a T for 10. Just so that I don't get, it's going to be, I don't want it to be 3 digits and sometimes and 2 in another. I just don't want it to be weird. Okay, so, or is it more weird? Well, I'll just put it back, just so you know I get OCD about these things. Okay, so I'll just put this back how it is. Okay, so 10 of 10, 10, Jack, Queen, King, Ace, and then when it comes to the suit here, if, you could use a switch, but I'm not going to. If suit equals hearts, this is where it's kind of cool, but it won't work. It just won't work. I could print out this, and you're like, well, okay, it prints there, but whatever font Visual Studio has been using lately, I think you get a warning. I don't know what the heck that's all about. And then you go, okay, this character cannot be represented in the current code page. So it throws off everything nowadays, unfortunately. And if you want to, I think you can say, maybe this will work. Static cast into a character the number 3. I don't know. This at least gets around the compiler warning. And so coming back, let's just see what happens if I go ahead into source here and just say, okay, try to print. Now I got to go back into the deck here. And instead of saying see out this, what I can say here is now what I can do is I can set up a card pointer card. I said pointer, card pointer card equals new card. And I can pass in the rank and I can pass in the suit. And what I can do here is I can print out the card and see what comes up. And now that's not good. All that's doing is printing out memory addresses. So how about I do star card? That's not happy. No binary that takes type card on the left-hand side. I get so used to using the operator overloads, I forget that I was using the print function. So I new up a card, I print the card, and then I go to the next line. So this should do it now. There we go. The 7, yeah, and this is what I was saying, like that character does not come in this font, so it's pointless to do something like that at this point. It used to do it. It used to be so cute and cool. Maybe there's a different font, but I've never played around with it. So instead of doing things this way, I'll just print it. I'll just have it print out in H. Else if it's a heart, do that. If it's diamonds, do that. If it's a club, do that. And if it's a spade, do that. And let's see what comes up now. And so there we go. Now we have everything. 2 hearts, 2 diamonds, 2 clubs, 2 spades, 3, 3, 3, 4, 4, 4, 5, 6, 7, 9, 10, jack, queen, king, and ace. And so now we have a representation for every card. Again, it's not graphical. It's text, and it's as minimal as you can get, but it works. And you finally got that done. So what else can we do with a deck of cards? Let's discuss that. Oh, I guess before we discuss that, just so you're aware here, I newed everything up here. There's new. I newed up every one of the 52 cards. Notice there's no delete here, because especially right now, if I deleted everything I just newed up when I got to the end here, then I'd have no cards. They'd all be deleted out. The deck would be hanging pointers or null pointers and all sorts of crazy stuff. I try to use them, things go wrong. And that's why we have this destructor, this explicit destructor that goes into the vector during the destruction process and eliminates and deletes all of those pointers, or all the memory that we've newed up. So every new gets a delete. It doesn't always occur in the same function, and it doesn't always occur in the same class. Like sometimes you knew something up in one class and you delete it somewhere else and things like that. And especially now with the more modern ways of using the different type of shared pointers and things like that, sometimes you don't even have to worry about that anymore. But for this example, the way I'm old school here, this is how I'm setting everything up. Okay, so I want to be able to shuffle the deck of cards. So again, I don't have anything printed here, so maybe I'll transfer over. I'll do a shuffle and I'll do a print for the deck of cards here. So let's look at our deck here, and I'll just set up a void function to print. So it'll be, instead of a card printing, it'll be the whole deck printing. And then I'll also set up the shuffle function. And they're void functions. They don't really have to do much to tell anybody anything of what they're doing. So let's go into card CPP here. Where's my function here? Oh, that's my card. Sorry, where's my deck.cpp? There it goes. All right, so for this one, does it? No, 3, 4, 3, 5, whatever. We'll just see what we can do here. We'll just say for every card in my deck, card pointer in my deck, I'll just say card.print. So the print function for deck calls all of the print functions for every one of the cards. So it's like it's deferring to something like this. We'll handle shuffle Well, actually, we can just do that real quick here. I'll need to include algorithm to make this thing work. Random shuffle. And I'll say deck.begin, deck.end. And it's not up to you to put in here anything when it comes to srand or anything like that. That's up to, say I'm just supplying a function that will say shuffle. It's up to the person on the other end to determine how they want to seed and if they want to do anything new. And if you do want to set up and make things more complicated, then that's on you. I'm just showing you the simplest way. This will actually go ahead and shuffle everything. And now when I go to run my program here, where's my source.cpp? I can say deck.print. Oh, I should probably put did I do that already here? Let me see. I should print, and then I should print out a space between everything here. And do anything. So give me 1 second here. I set up my deck of cards. I print. Let me see. Let's just see what happens here. Okay, my deck has 0 cards in it. Oh, do you know what I did? I know what I did. In my deck of cards here, I was very good at setting up the pointers for everything, but I was very bad at going ahead and saying, hey, deck, why don't you put this card inside of there? So this should fix things up a little bit nicer. And so now the deck holds 52 cards. They are all happy. And now I can go ahead F10 and print. And now you can see in a little better format, there's all the 2s and all the 3s and everything, so forth and so on, all printing out all 52 cards. And now if I want to see things a little better now, I can also go ahead and say deck.shuffle. And there we go. So now every time I run this, the 5 of hearts is going to be the first card. The 5 of hearts is going to be the first card. So again, I was saying it's up to me if I wanted to set it up. I'll have to use ctime here. If I wanted to randomize everything, that's not the library. It's ctime. This is not the place. Like I said, your library code is not the time and place for these kind of things, for setting up what gets randomized and what not. So 5 of spades, 4 of diamonds. So now it's completely different every time. So again, that's up to you on the main end, not on me on the end that's developing the library. So I've got shuffle, I've got print. So let's see, 2 other things we can do is what's the card at the top of the deck, and then we can also go ahead and say, what I want to do is pop off the top card of the deck. So I think I would like these to be 2 separate functions, because there are times where I want to just get a card off the top of the deck, and basically trash it without looking at it. And there are other times where I want to look at what the top card in the deck is without trashing it or without dealing it or without anything else like that. So I'm going to set up here, and I'm going to say I'm going to return a card pointer, and I'm going to say get top card. Or I guess I could just say top card, because you're like, if you say deck.top card, you know what that means, right? Like, get me the top card. And then I could also do something here, like a void function, and just say pop card. Top and pop are very when you're talking stacks and queues and things like that. And so maybe, just maybe, what I want to do is turn this vector into a double-ended queue, a deck. And the reason for that is, when I'm going ahead and doing this thing, if I just go ahead and just burn off the card, I don't want to just delete the card, because maybe I want to reshuffle. Maybe I want to take the deck of cards and shuffle again. So my thought process is, top card is easy, just get me the top card. But when I pop it, I take the card from the top of the deck and I just place it on the bottom of the deck. And that way the card, I've done this with board games and stuff like that, right? You don't just rip the card up and just burn it unless it's one of those legacy games or something like that. You generally keep the card around. So that's what I'm trying to go for here. And so to fix that up, I guess we could just fit double-ended queue. And I don't think I have to change anything else other than I have to include a double-ended queue instead of vector over here. And let's see what that does on the build side. Oh, I did get something. Oops. Where is the actual error? And, oh, the error just comes with the reserve function. There's no reserve when it comes to a double-ended cue. But other than that, let me try now. Yep, see, there you go. And this is just because I don't want to spend the time to make this nicer, to make this so that we don't get that compiler warning. But now the double-ended cue is working. I can push back, but maybe I should push front. It really doesn't matter, but it just makes sense, visually to me that the front is the top of the deck and the back is the bottom of the deck. So maybe, and it really doesn't matter again. Push front, push front, push front, push front. Well, actually, maybe it does, but when it comes to shuffling, it really doesn't, because if it's I'm just mumbling, I'm just rambling. But if I as long as the cards get shuffled, it doesn't matter if I shuffle to the front or the back, it'll be shuffled. So I'm just going to leave it as is. Okay, and shuffle will work exactly the same because of the way a deck works. And so let me go back here and set these last two things up. Let me set up these functions. Here we go. So, all right, so the top card function, instead of returning null pointer, I am just going to pass and just return deck dot, and I can get front, right? I can just return front. And that will return the front item, which is a card pointer. It returns type T. Our T is card pointer. Deck.front. And now in this case, what I want to do here is, so I want to make sure I can move the card from the front to the back. So I can say deck.pushback. And now I can say deck.front. And I can, say, when I copy this, when I say, okay, push to the back, the pointer, I'm not newing up any memory. But for this brief moment right here, when you hit this line of code where I put my comment in, for a brief moment in time, you have copied and created a second pointer to that deck. But technically, you have two cards of the same type in the deck, because we're kind of doing a flyweight pattern in a way here. We're not really doing anything complicated. But so I still need to delete. I just got to remember how to do this. Find the erase function. There we go. And I can just say deck.begin. So then copy the card from the front to the back and then erase. And that should do it. When I'm dealing with popping the card off the top of the deck here. So we can try this out over here. I can say shuffle print. Okay, I got shuffle. I got print. I can say card pointer card equals deck dot top card. I could say card dot print. Just print that one card, and then I can just I'll just do an end line just to be safe on this. Oops, I don't have include for my IO stream. And now I can do it. And so now I can go ahead and say, okay, I want to take my deck and I want to pop the top card off the deck, and then I will print the deck again. And I think I should probably, every time I print the deck, I should probably do a new line. And let's see what we get. All right, so I say, okay, King of Spades, bunch of cards. The King of Spades is the top card. And then so the 8 of Clubs is the second card, but I said now pop that card. So technically, let's say, like, what happened is, if you want to think of it this way, there are now 2 copies of this King of Spades out in the world. The King of Spades is technically in my hand. The card variable is holding the pointer to that object. But just so we can maintain this object and not have it destroyed, and just keep track of who's maintaining all of these things, I move the King of Spades to the back. But now I have 2 things pointing to this. There's a pointer inside the vector, or the deck inside of the deck object, the deck of cards, and now there's a pointer pointing to it here, the card pointer. See, and you have to watch out. You don't just because I have a card pointer doesn't mean I want to delete this later on. But that's all there is to that. To top card, top and pop, and now the sky is the limit. If I wanted to play blackjack, I would just do get me the top card, pop it. Get me the top card, pop it. Those are my 2 cards. Or or a 5 or poker or something. Get me the top card, pop. Get me the top, pop. Do it 5 times, so I have a 5-card hand. or a 7-card hand or anything like that. So that is pretty much, at least to get going here, a basic deck of cards. I've got a deck object that manages a double-ended queue of cards. Everything's pointers everywhere down the line, so you can see how things are starting to get a little more advanced here when it comes to setting up pointers of things, maintaining the pointers, deleting the pointers so that you don't accidentally have a memory leak somewhere along the line, because that would be terrible. Shuffling the deck and all sorts of things. And now it's all up to you. What do you want to do outside of what I've done with this card class? So as always, thanks for sticking this out with me. If you have any questions, email me at swardb@cod.edu, or you can comment below here on the YouTube channel, and I'll get back to you whenever, as soon as I can. Thanks, everybody. Have a great day.